Okay, let us now look at question 4 in the workshop. So we've got a 5-bond portfolio. So let me just put the details on the board. And we don't have the number or the price of the bonds, instead we have the amounts of each. So 25 million invested in bond 1, 100 million invested in bond 2, 75 million in bond 3, 20 million in bond 4, 200 million in bond 5, and we've got the modified duration. So the modified duration. Remember, the modified duration is Macaulay's duration divided by 1 plus the yield to maturity. So the modified duration is 10.5, 4.5, 7.5, 15 and 2.5. So we've got the largest amount, as you can see, 200 million, the shortest duration bond. Well, if we'd like to work out the duration of our bond portfolio, we need to work out the following. The duration of the portfolio is the sum from I equals 1 to n of each bond, where it's just simply weight of the bond times by the duration of the bond. So let's just work out the value of our portfolio. So I'm sure we can do that in our heads. So 25 plus 100, 125 plus the 75, 200, 220, 420 million. So let me just work out the weights of each bond now. So 25 divided by 420, you can see that's 5.9% or 5.95. So that's 0.0595. 100 divided by 420, you can see is 23.81, so 0.2381. 75 divided by 420, you can see is 0.1786. 200 divided by 420 is 0.0476, and 200 divided by 420 is it's going to be 10 times that one, 0.4762. Just to make sure I haven't made any mistakes, I'll just add all of these together. 0.0595 plus 0.2381 plus 0.1786 plus 0.0476 plus 0.4762, and this sum to 1. Now we simply need to take our duration, which is this, and multiply it by the weights, and add them together, as so. So if I now do that, so the duration of our portfolio, if I now take this times by this, this times by this, this times by this, this times by this, and this times by this, we'll get the answer. 0.0595 times by 10.5 plus 0.2381 times by 4.5 plus 0.1786 times by 7.5 plus 0.0476 times by 15 plus 0.4762 times by 2.5 gives us an answer of 4.99 as the duration of our portfolio. It's not quite in years because, of course, that's in years and we divide it by 1 plus the yield to maturity. So that's the duration of our portfolio. The next part of the question said, if you expect the yield to maturity to fall, how might you reshape your portfolio? Well, let me just delete some of this material. Well, no, let's not, because I'll need to refer to it. So instead I'll just delete the weights. And remind ourselves of an equation, that the change in bond price is equal to minus D, and if I'll use modified duration now, times by delta 1 plus I. So if we expect this to go down, so if we expect the yield to come down, because of this negative sign here, then this will go up. And the magnifying effect is driven by this. So at the moment, let's call this 5. It's going to equal minus 5 times by the fall in price. So it's magnified by a factor of 5. So if we really expect the yield to fall, we may wish to place greater emphasis on the larger duration bonds, i.e. this one here and this one here, or in fact this one here. So those are larger duration bonds, and of course this was rated as B, and this one here was rated at AA, and this one here was rated at AAA, and this one here was rated at AA, and for completeness this one here was rated at AA. So we had the largest amount of money in our portfolio on the AAA rated bond, this one here with the short duration. Of course we could put more money in this bond here with a duration of 15 years, but it's rated B. So by shifting more of our wealth towards the longer durated bond, we have to also consider the fact that its rating is worse, so that we're increasing the risk of default on this particular portfolio. So because of this relationship here, and that duration is a linear weighted average, we can shift some of our funds towards this bond here, but of course by doing so we're increasing the risk of default. I hope that's clear.